Welcome to my home. Hi, I'm Phil, and I am the Director of Training for Sound United, which is a large amount of consumer electronics brands. And if you don't remember, the brands are Denon, Marantz, Class A, Definitive, Technology, Boston Acoustics, and Polk. And assisting me today is Jim and Jennifer. They will be assisting me by answering questions as well as posting handouts and things like that. We just did this session a few earlier, and it went for literally almost 2 hours because of all the questions. So what we're going to do this time is I want you to insert your questions, put your questions in the chat area. We will be posting 2 videos. One is the presentation of me going over the material, and the other one will be just the answers to all of the Q&A. That way you end up with a more bite-sized presentations, an hour of presentation, and if you really want to get into the Q&A, an hour of Q&A. This is about long-distance HDMI. If you have any questions about what's a K and what's 444, and can you explain how to do this with an AVR? All that stuff has probably been expressed or answered in a previous presentation. So in order to make it more worthwhile and more effective for this presentation, we're going to try to limit it to cable-based discussions until we get to Q&A. And after we answer the cable stuff and we still have time, then we can get into functionality and things like that. If you need that additional information, guaranteed, if you please subscribe to our Sound United training channel, and guaranteed that information is probably available in one of the sessions we've done. I have done a 3-part series just on HDMI 2.1. So we talk about bandwidth, what's in the cable, what's 444, what's the video formats, how the video formats, what are the features are available in 2.1 besides just 8K and 4K 120. So there is literally, when you combine this session with the other sessions, over 4 hours of information specifically on 2.1. So please subscribe to the Sound United training channel for that information. Plus, we also have other content as well on this site if you have problems with your HEOS and things like that. But today, long distance HDMI. So we wanted to take some time and talk about HDMI 2.1. And the question I always get is, wait a minute, Sound United is an audio company. Why are you spending so much time talking about HDMI? Well, yes, a lot of times when people think about HDMI, they think about it as a video form, as a video format. But you got to remember that along with that movie, the image of the movie is also the sound. So HDMI is critical when we talk about getting better performance from the products that we sell to you and to your clients and your customers. So we want to make sure that there is to minimize the amount of confusion when it comes to HDMI, so you don't blame our black box for problems and issues you have when it comes to HDMI, especially which arise when we're running longer distances. Well, the first thing that I have to get across, if you walk out of this, is do not use the Toslink or optical cable. I know a lot of you guys are old school and you hate eARC, but here is a fact. Most optical outputs on most TVs do not support more than stereo from this optical connection. So a customer goes out and buys the best Denon receiver and an $8, $10, $12,000 8K TV, and he decides he wants to watch fill in the blank application in 8K on his 8K TV, and it says it's in Atmos, DTS:X, IMAX enhanced, whatever you talk about. And if you connect it with this Toslink cable, they are going to get stereo. That's it, stereo. Toslink cables for most TVs do not pass surround. Could a Toslink cable pass surround? Yes, it does. It could. However, most TVs take the information to share down its Toslink optical out after it has been down converted from surround sound to stereo. So there's only a few TVs, like Sony TVs, if you set them up properly, can pass multi-channel surround through an optical on some applications. But to cover your bases, do not use Toslink, because for 99% of applications, for most customers, you're not going to get what you're looking for. So guess what? You have to use eARC. I know most of you people, some installers think that eARC is the devil and they don't want to use it because they've had lots of problems. eARC and eARC have been improved. They continue to be improved. And whether or not you like it or not, if you're trying to get great sound from a TV's internal applications or a device connected directly to the TV, the only way you're going to send that sound from that TV to the receiver and get it in surround sound is going to be in either audio return channel eARC or enhanced audio return channel, because they support most of the Dolby and DTS surround formats. To utilize eARC or eARC, there are cable requirements. eARC does have more data, so you need to make sure you have a cable that has an HDMI with Ethernet compatible cable or balun or extender in order to do that. eARC can support compressed multi-channel, but because of its bandwidth, it cannot support uncompressed. eARC can also sometimes, on some TVs, support Atmos and DTS:X, but it is a limited amount of televisions, and those TVs have to have a Dolby Atmos encoder built in. So we said we're not really going to mention it there. eARC can support uncompressed multi-channel, the same that we found on your Blu-ray, as well as object-based True HD and DTS master audio. So the same quality that is found on your Blu-ray player. There is a thing that we must talk about. eARC is part of the HDMI feature set that is part of the HDMI certification, HDMI, not even certification, the HDMI standard. However, not every TV supports all of the features in the 2.1 standard. For example, Samsung TVs support things such as variable refresh rate. They're going to support quick media switching, but they're not going to support eARC. Right now, officially, they don't support it. LG and Sony support eARC, but they may not support some of the other features. The only way you're going to find out what features that particular TV supports is to look at the specs on that TV. Even in brands, if you look at the same brand, there will be some series that support more 2.1 features than others. So the only way is to look at the unit itself. But eARC is going to be critical when you talk about utilizing content in this new world, whether you like it or not. And I come from the CI world, and I know that for reliability before and control capabilities, I put all of my sources in this rack, and then I plug everything into that processor, and then I send just the video to that TV. But certain services are not available in outboard boxes. So let me give you an example. IMAX Enhanced. Sony has announced they're going to be releasing over 100 movies over the next year in IMAX Enhanced, which is a variation of DTS:X. Those movies, Sony's TVs have a service built in called Privilege. I can't even pronounce it right, but basically it's a service where they can actually have IMAX Enhanced movies on it. That is not available on any external box. So if you want that IMAX Enhanced sound from that IMAX Enhanced movie, the only way to get it is to send it from the TV back to the receiver via eARC. So customer buys a top of the line Sony TV, he sees that there's all these IMAX Enhanced movies and he wants to play it, and you have connected it with optical, he gets stereo. Not IMAX Enhanced audio, not DTS:X, not multi-channel, he gets stereo, and they're not going to be happy with you. So whether or not you like ARC or not, you're going to have to accept it and there are ways to make ARC more reliable. And the TV manufacturers and the AVR manufacturers like us realize that ARC is critical, whether it's ARC or eARC, and it is getting more reliable. So don't worry about if you had problems 4 or 5 years ago. They're working to make it better. All right. So because the new standard has way more a higher frame rate capability, up to 120 frames per second, and 8K resolution at up to 60 frames per second, the current cabling cannot support that. In addition, there are some additional user enhancement features that will make gaming better, that have nothing to do with resolution, that will make watching video better, that has nothing to do with resolution, that are part of this HDMI 2.1 standard. So whether or not you care about high frame rate or whether you care about 8K, there will be some advantages to the 2.1 standard for basically everyone. There's some things I want to get across. A lot of times when we talk about 8K 60 or 4K 120, the only sources that are currently being announced, that have been announced, are gaming. And there's a lot of, and there's 2 gaming systems coming, the Xbox, the new Xbox, and the upcoming PlayStation. But let's talk about us people who are just movie fans. If you're not a video gamer, let's look at some facts about that you need to understand if you are a movie fan. And this is going in a theater, and you're going to just play movies on it, not video games. I want you, the question is, do you actually need 40 gigabits per second? And to be honest with you, it's probably an absolute no. You probably don't. So the first thing, there are no external 2.1 movie sources available. So we're talking about there is no 8K Mega Roku or 8K Apple TV. They don't exist. They have not been announced. So there's no physical thing to put in the rack. Okay. Number 2, there is no physical media. The current UHD Blu-ray, its compression capabilities, you cannot fit a 8K movie on the standard UHD Blu-ray. They would have to come with a whole new compression scheme, a new standard, in order to do that. If I've tried to put an 8K movie on a UHD Blu-ray, I would be changing discs. It'd probably be like 4 or 5 discs in the pack. And I would be changing discs and flipping it over, almost like a laser disc that we used to have to do. So there is no physical media. And finally, there are some companies that are working on, that have boxes available for set-top boxes, but no cable or satellite company has ordered them or planning on using them at this time, or have announced that they're going to use them at this time. Well, let's talk, and there's a reason for all of this. Number 1, no standalone streaming devices. If I make a streaming device, what am I going to play on it? There's no 8K content that's really being distributed now. Movies are shot in are not shot in 8K most of the time. They may capture the video footage in 8K, but they do not shoot the movie, and they do not distribute the movie in 8K. So captured in 8K, distributed in 4K. Why? Because they make hundreds of millions, billions of dollars in 4K theaters. Making an 8K movie for a 4K theater is a bad business decision. They're not going to do it just because a couple of consumers have 8K TVs. The next thing, the cost of the movie goes up. The file size to produce it. So not only do I have no place to distribute it, it costs way more. And the cost increase isn't going to be made up because a couple of customers have 8K TVs. It's just not going to happen. All right. The next thing, TV companies aren't really shooting much in 8K. Why? Because right now, think about how many 4K channels you have. Every once in a while, they may do a special event in 4K, but there's not very many 24-hour 4K live broadcast channels. Would you agree? Because to give you a 4K channel, I have to give up 4 HD channels. And cable companies like saying they have 200 channels or 300 channels. That's a better marketing deploy than I have 75 channels, and 2 4K channels. So they don't want to give up channel space. If I go to 8K, I have to give up 16 HD channels. How many broadcasters, dish network, dish companies are going to give up 14 13 or 16 channels to give you one 8K channel 24 hours a day. So, and if I did that, what am I going to play on it? Because no one's making TV shows or shows in that particular format. So, no movie distribution, no set-top box, no streaming box, no 4K, no 8K content really. The only 8K content you may see would be TV manufacturers that make 8K. A lot of times sponsor, as I said, internal apps on their particular television sets. Sony and Samsung were the first ones to release 4K content for their TVs. It was built into the TV. Samsung had a hard drive and Sony had a 4K player. They were the first ones to release 4K and HDR content, but it was specifically shot and sponsored by that company, and it was played back on an app built into their TV. Hence, you're gonna need eARC because you can't buy an outboard box like the one behind me in order to play that stuff back. So you may not need 48 99% of the time. It's a peace of mind type of thing, but it is not something that you absolutely have to have. Now, especially if you're a movie person. If you're a gaming person, it's another situation. Gamers like higher frame rates because it makes the gaming smoother, which makes it gives them better motion, and so I like the high resolution and the high frame rate because it gives me an advantage. So if you have a new gaming system or one of these big PCs the size of a refrigerator and you game hardcore, there are some advantages to higher frame rate 4K. We mentioned that there is not much 8K consumer content coming out at this time, but there will be just chances for 8K distribution of content for professional applications. The benefit of 8K is I can get incredibly close to a very large display to look at details. So if I want to send MRI videos, or if I want to send some sort of content, and I want some sort of content into a lab or an engineering facility, and I really want to critically look at the small, fine details, there are definitely applications in professional applications. So whether it's medical, whether it's engineering, whether it's architecture, being able to look at a schematic and go and look at every little fine detail while you're going over a building as an architect from my computer on the other side of the room is a good thing, okay? So you will see 8K used a lot more for professional applications at the beginning than you will see for consumer applications. Most of the 8K TVs that people are purchasing, well, most of the time they will live as just as a way of by upscaling 4K to 8K. But true 8K, you'll probably see it in more industrial applications from clients. If you guys do professional jobs, more than you will see content available for the average consumer. So before we can talk about long distance solutions, and some will work and some will not, but we have to talk about how a cable works inside, an HDMI cable works inside, which will help you understand why those limitations exist. So the first thing, there's 19 wires in an HDMI cable. The video is sent down what are called TMDS pairs. There's currently actually 3. You see in this cable, there's 3 big cables or 3 big lines. And then you'll see another one right above those called the clock pair. Well, that is another TMDS line. It's just used for syncing. The other 19 cables, in the other 11 or 12 cables in the wires in this cable are used for things like 12 5-volt voltage, CEC, ARC, audio, everything else. So audio does not go down these TMS pairs, only video. So when we talk about eARC or audio or compressed audio versus uncompressed audio, that has no real effect on these other video sides of the line. They run down different cables or different lines. So if you look inside here, you'll see that there's actually 3 TMDS channels linked to really close together. Channel 1, channel 2, channel 0, channel 1, channel 2. Well, the way a cable works now is each one of those cables carry 6 gigabits of data. 6 plus 6 plus 6 equals 18. That is why the standard for HDMI 2.0 and 2.0b, the maximum you could get was 18. 6 gigabits per channel. This other channel right here is just the clock channel. And if you looked at that, remember that diagram I just showed you, that clock channel wire on some cables, that clock channel is a smaller gauge, a thinner wire than the other TDMS channels, because it only was designed to send, clock timing to make sure those other the three channels were in sync. Well, with 2.1, the whole way that your display and your source looks at a cable and how it uses the wire in the cable has changed. This is why you cannot do a firmware update to go from HDMI 2.0b to HDMI 2.1. It's a physical new way for a device to look at a physical cable, how it looks at the pins on the cable. So you need a new board in the receiver and a new board in the source and a new board in the receiver in order for this to work. So if you look here, now there's 4 lanes. It took the clock channel, which was lane 3, which was just a clock, and now it also carries data. So if I have 6 plus 6 plus 6 plus 6 equals 24. So immediately I have 24 gigabits per second of data using the existing cables that you have now. If you have a good 18 gigabit cable and all 3 lanes are the same size, all 3 wires in that cable are the same size, that cable is pretty much immediately a 24 gigabit cable. And that may be enough to send all the data you will ever need for the display that it is connected to. So old system, 3 of the 4 channels carried video, and the 4th channel was for timing. New system, all 4 carry it, which gets us up to 24. Then they said if I increase the amount of data going down each channel from 6 gigabits per second to 12, I can get up to a total of 48. So ta-da! Now I'm at the standard that we're talking about, 48. But you may not even need 48. And we'll get to that. The next thing is that cable, it gets harder and harder to pass bandwidth as the cables get longer and longer and longer. We all know it's easy to find, there's a million cables that are 3 feet long that will support 4K 60p HDR right now. But there's very few cables that are 30 meters long that can support 4K 60p HDR. So the longer the cable, the harder it gets to transfer the data. It's almost like if I want to pump water long distances, I want a bigger pipe because it's easier to pass the data down a bigger pipe. If I want to pass data a longer distance, I need a bigger gauge wire, which is why some of these older HDMI cables that are not active look like ropes, because in order to pass long distances, it looks like a rope. Now, you may see really, really thin older HDMI cables. Let me pull one out here. You may see really thin older HDMI cables like this guy here. This is an older HDMI 1.4 rated cable. Looks really, really thin, but it's pretty long. This cable, if you notice, you'll see cables that have a source and a TV, or a source and a display labeled on the ends. Those cables are all active cables. This is what's called a red mirror active cable. In order to run a thin gauge and make it really flexible, it is amplified, okay? And it is one way. So it needs to be connected in the proper direction because the amplifier is in the tip labeled display. If you connect it the wrong direction, it does not amplify and it does not work. So if a cable says display and source, or TV and source, it is always an amplified cable, and that cable is a one-way cable. If you put it the other way, you're not getting the amplification and it will fail on you, all right? Or it may not be reliable. The next thing we got to get across, balance. Everybody loves balance, or balun is the old school name for it. That balun basically stands for taking something that is one format and switching it to another. So it goes in as HDMI, it's converted to a Cat5 or a Cat6, and then when it gets to the other side, it is reconverted from Cat5, Cat6 back to HDMI. Now you hear the term extender a lot more than balun. So a balun is what it's doing, extending is the benefit. Most HD-based T baluns do not support ARC or eARC, and most do not support above 10 gigabits per second. That's just the limitations of HD-based T. If they do, it will be labeled all over the box because that is an enhancement feature. There's only a few select HDMI extenders that will support ARC. Here are two. I have been, over the last few years, I run around at every show and I ask every cable manufacturer, because it's almost like a hobby for me now. I got hundreds of pieces here. Which device supports, and I say the bandwidth 18, and which ones support ARC? They will talk about or HDMI ARC, not just ARC, but HDMI ARC, and they'll talk about where they have optical ARC transfer and it supports 422. That is a way of basically giving you a load of baloney, because if it supports ARC, they will put it all over the unit because that is a premium feature. So for example, on this one here, this is the Metra piece. Oh, I'd like to thank companies like Metra and AudioQuest and as well as AV Pro Edge, AV Pro Store, that to give me all of these samples. So this is a AV Pro Edge balun, and right here under HDMI, you see it says ARC. All right, it says ARC because it is a feature that costs a lot of money. These baluns are $1,300. $1,300. Why? Because they support ARC. Most other companies, if you look here, when they say they have audio return channel, you'll see that there is a Toslink there. What they call it is optical audio return channel. It takes you take the optical out of your TV, you plug it into here, and then it will send optical to the other side, and then you plug optical into your receiver. The problem with that is optical Toslink only from a TV only provides what? Stereo. So if you use the optical audio return from your TV to the receiver, you're only gonna get stereo. It has to have ARC, HDMI ARC output if you want the balun to send surround from your receiver to your stereo. The next thing is HDMI baluns are HD-based T is limited. The maximum that an HD-based T system can support is 10 gigabits per second. So what these do is, if you look at these two systems, they use compression. AV Pro Edge calls it invisible compression technology. This one other company calls it 2-to-1 data compression. And what it does is it's 18 going in one side. It is compressed to the maximum that HD-based T can supply, which is 10 gigabits per second. It is sent down the line, and on the other side, it is uncompressed. So it's lossy compression. If I put my test pattern generator on it, I see 18 in and 18 out, but the wire in the middle is just 10. Okay, that's something that I really need to stress. If there's a lot of times these baluns that can support 18 gigabits per second and ARC at $1,300, you can go out and get a very long fiber or optical active HDMI cable to do the same job. The benefit of these is, say you've already pulled the wire in the wall, 2 Cat6s, and the customer's swapping his 4K TV for an 8K TV, and he wants, and you don't want to have to pull a whole new piece of copper in a whole new piece of optical through the wall because you didn't put it in there. This allows you to retrofit your system, and even at $1,300 for these, that may be less than the cost when you combine the cost of an optical cable, optical fiber optic HDMI cable, with the cost of the labor. So, but they're expensive, and if it does it, the manufacturer will list it all over the box and all over the unit. All right, so the next thing, bigger is not always better. So we keep using this term 48 gigabits per second, but 90% of the time, for most systems, you will never need that, ever, when it comes, especially with any display that is available today. Putting a 48 gigabit enabled device, cable in the wall is just for peace of mind, not for anything that you will need it for the next several years. And there's a couple of reasons for that. The first thing, another part of HDMI 2.1 standard is compression. It's called DSC. And basically, the board that's in the source can compress a signal and losslessly. And then the display device can uncompress the signal losslessly. So I could take a even bigger bandwidth and shove it down a lower bandwidth cable. So that is part of the compression scheme is part of the standard, and it works incredibly well. So Jim posted a version of this chart that you can download. And this chart was provided by Noridio. They actually own the AV Pro Edge, the people that make the baluns, as well as video distribution. They have always been a very good partner, and they've always been kind of at the cutting edge of this stuff when it comes to not only honesty, but giving out the facts as the facts. So they came up with this chart of data rates showing how much bandwidth you need for certain types of content. So the first thing I have in here, of course, is our regular 8K 30 8K TVs. Most movie enthusiasts only are concerned with 8K 24 because they want it to look cinematic. When you talk about 60 or higher frame rates, they don't like that. It looks like video, and the movies are shot in 24, so they want to show it in 24. So if I go to 4K 24, you'll see there's three standards here. If I do 444, 10-bit or 444 12-bit, I can get up to 18, which is the maximum of the cables that we're talking about that were available last year, and that is the maximum you can get from a source that is available right at this second. But if I drop the subsampling from 444 to 422, notice that I cut the bandwidth in half from 18 to 9. There's a couple things I want to point out about this. What lives on a 4K Blu-ray is 420. Something has to convert it to 444, because when you watch TV, you see all the colors, all the red, all the green, all the blue. 444 basically means it looks at all three colors, or all the colors, all the time. And 422 means it looks at one color all the time and the other two colors every other time. And the TV or display or product or source uses mathematics to convert 422 to 444. Most boxes devices default to 422. Leave it there. It makes the file smaller. Your cables, when you run longer lengths, will be more reliable. The length that a cable is effective will almost double if you do not turn this from 422 to 444. Okay, so keep that in mind, and we'll get back to this chart in a little bit later. Oh, there's a few more things. So say I want to get into, we'll go back. Say I want to get into 4K at 120. That is down here, right here, 4K at 120. If I go here and I set this cable to 422, which is what it should be set to, 8 to 12-bit, it's only 32. If I apply compression, it is 9, okay? If I go to what's actually probably going to be encoded on the physical media, when you get your download service or you get your Magic 8K disc, it's probably going to be 420, 10-bit, and that is 24. Or if you compress it, 9. If I go to 8K and I go to 444, 10-bit, the maximum is 40. Now you notice I don't have 444 12-bit labeled on this device. there's two things I want you to get from this session if you're going to be using long HDMI cables. Number one, never set something in your device, your source device, to 444. You're making it harder in your system and you're making your cables less effective. Number one. Number two, never set something to 12-bit. Why? Because 99.9% of display devices are only 10-bit, period. Projectors, except for maybe one or two JVCs that they say they do 12, but everything else, Sony projectors, BenQs, Epsons, Sony TVs, LG TVs, Samsung TVs, Hisense TVs, Panasonic TVs, they all use 10-bit OLED and 10-bit LCD panels, 10-bit. So you giving it 12-bit is not going to magically make that panel 12-bit. So going above 10, you're wasting data. You're wasting data. Don't do it. You're just making your system work harder. So if I stick to the maximum capacity of a 8K TV, that would be an 444. Even if I turn it to 444, which I shouldn't, 10-bit, which is the maximum of the panel, it is 40 when I play movies. If I put it like I should, 422, 10-bit, we're at 32. If I go to 420, 10-bit, I'm at 24. Now, even if I get really carried away and I say, well, what about 4K 60, 8K 60? They keep talking about 8K 60. If I go down there to 8K 60, you'll see there is no 444 uncompressed. You can't do it. You can't do 444, 8, 10, or 12-bit uncompressed. It has to be compressed, and the compression makes it a total of 24. Uncompressed, I can do 420, 10-bit, and its maximum is 40. So there is very little time or very little need to go above 40. This 420 12-bit, you're wasting data because the TV is not a 12-bit panel. They don't exist, all right? So don't get carried away and crank up the big numbers, because all you're doing is wasting data and you're making your load harder. The next thing you got to consider is this whole new thing they added. It's lanes. Before, there was only 3 lanes of the old cables that we used to have, and 3 lanes at 6 gigabits per second was 18. That's the old standard. Now, there's 4 lanes, and if each lane can support 10 gigabits per second, you're at 40. So that is new, and you'll be able to test that using test pattern machines, which I will show you in a few minutes. So remember, Blu-ray, 4K Blu-ray, UHD, it's less than 8 gigabits per second because it is a 10-bit format, and it lives on the disk as 420. You cranking it up in your Oppo Blu-ray player or your Sony Blu-ray player or your Apple TV, you're just increasing the demand on your switchers, your cables, your receiver, and all of your TV and projector inputs for zero benefit. Let the expensive display device do the color upsampling. Okay, they call it chroma upsampling. Let that display do it, because it's going to be better than your $100 Roku is going to be able to do it. Certain numbers are more important than others. So if you look here, 8-bit 444 is a larger file, but it only has 16 million colors. 10-bit 422 is a smaller file, but it has 1 billion colors. The picture looks better with the smaller file. Don't be concerned with the 444 and the 422s. You need to be concerned with 10-bit. Make sure everything can supply 10-bit. One of the reasons why I bring this up is if a cable, all of those other numbers that you see, when you see a cable company talk about 444 or 4K 60 or 10-bit color, is a way to baffle you, because it really is about the data. If you look at a cable, if a cable can support 18, they will put 18 on the box. They will put 18 on the box. So, or if it can support more, they will put the number on the box. All the rest of the stuff is a way to dazzle you with baloney, because the cable probably can't support the number, because if it could, they would tell you about it. So don't be concerned, don't be baffled with these numbers, because a lot of times the bigger number, 444, may end up, it may only be 8-bit, but they're not telling you that, and you end up with a bad picture. They may say 12-bit, comma, 444, comma, 60p, comma, but they're not saying they can do all of it at the same time. So it's a way of baffling you. If it can do 18, if it's a balun, a cable, they're going to tell you. It can do 18, it can do 24, it can do 48. And they're not going to put that on the box unless it can, because they will get sued the second someone tests it, and it cannot. All right? So that's the number you need to be concerned with. These bigger fancy numbers, cranking everything up in your player, like your Oppo Blu-ray player, and turning everything to 12-bit 444, 60p, it's basically like buying your wife a fancy diamond ring, taking it out of its little box and sticking it in a shipping container. It's not going to make it any better. It's not going to make it perform any better. It just makes it harder to send the data. All right? So long HDMI cable solutions. There's lots of different cable solutions that can be out there. The first thing, the very best solution, if you can get them, would be our fiber optic cables. These are not the only solutions, but these are just a few that I have experience with from these companies that have sent me samples that I have physically tested, and I know that they will pass it, and and that is labeled all over the box. So when I say test it, there's most calibrators have the ability to have test pattern generators. So what I can do is, these are my two test pattern. So that is a generator and an analyzer. So I can actually feed it a signal, which is, let it focus up, a signal. And right now it is being fed, if I can get it to focus, 23 frames per second, 4K. And you can see the cable works perfectly fine. I get signal on both. If I go into this device and I turn it up to 60 frames per second, now when I come out of here, you see the other one, it says, drum roll please, no signal. So the system is now sending 60p, but this cable cannot handle it. Really quickly, really easy to check the performance of a cable using test pattern equipment. So no company is going to put 18 on a box unless they can do 18, because it can easily be checked. And if it's not correct, they could be sued for false advertising, the best way to think of it. So optical is the very best way to go. A physical cable, whether it's optical or active HDMI. I mean, you can do optical or active copper. Both of those pass 18 for longer distances. They all support eARC, audio return channel, because they look at all of the lines in an HDMI wire and send it down down from one cable, from one end to the other. The better balance, same thing. Make sure that it says HDMI ARC, not just ARC, because if they say ARC, a lot of times they're talking about that optical way of sending the sound from your TV back to your receiver, but that is only in stereo. It has to have HDMI ARC, and it needs support to support 18. If it supports 18 gigabits per, they will tell you that. Then there's some other things you got to look at. If you look at the AV Pro Edge model is $1,300. The other unit is less expensive, but it can't do dynamic metadata, so it can only do HDR10 HDR. If you want Dolby Vision, HDR Plus, HDR10, and ARC for distances up to 100 meters, and you want to use a single Cat 6, the AV Pro Edge is pretty much the king. I have yet to find another unit that can do as much. If somebody has another one that they think will work, please put it in the chat, and I will be happy to actually mention that unit as well after I check it out. Okay. The next thing, not only can you use HDMI cables with the fiber built in, you can also just run the fiber in the wall all by itself. I kind of like this because this wire is good for way beyond 48 gigabits per second. I put this wire in the wall and I want more capability from this wire. All I have to do is update the balance or the extenders. Currently, the HDMI extenders that are available on the market today only go up to only been certified up to 18. And there's a reason for that. Just like there's a new board for in the receiver and a new board in the TV and a new board in the source device, they have to put a new board in these baluns so they can communicate the same way. So most of them are limited to running the video down 3 channels, not down 4. So that's why these are limited. Even the very best ones are limited currently to 18. It does not mean that they can't make a new version of this that looks at all 4 that communicates video down 4 lanes like a physical cable will do, and these will go up. So it's not the limitation of the cable; it's the limitation of how these extenders communicate with the devices they're connected to. And of course, there's another brand that offers some Zygen. I was online for the last few days looking for HDMI fiber baluns that support ARC, and of course the one I talked about before, which I have in my hand, which is the AV Pro Edge. If you look at the AV Pro Edge model, you'll see right here it says HDMI. It says ARC on it. All right, and and on this box here it says ARC. If these fiber adapters can support ARC, they will put it all over the device, okay? So they make sure they will highlight it on its particular device. You need it. As much as you don't want to use it, you're gonna have it. All right, the next thing. We talk about fiber baluns are expensive, but they give you upgradability. We talk about the high-end HD-based T units are very expensive, but they allow you to retrofit older jobs and get a little bit more out of it. If you're going to run something new in the wall, there's already optical cables, active HDMI, whether they're optical or active HDMI, that are already rated to at least 24 gigabits per second. The cable that I showed you earlier that is rated for 18, they went back and tested all 4 channels and bumped it to 24. I can't reach it. I have to grab it a little later. So there are cables already that are rated for 24. Remember I told you that if you're watching 8K at 10-bit at 24 frames, which is a movie, 24 is going to be enough for a movie customer watching a movie on an 8K display. Or even a gamer playing games at 120 at 10-bit. Okay, so there is enough data just with these cables, and these can go up to 100 meters, 330 feet. The next thing is, of course, there's going to be new 48 gigabit cables coming that are going to be certified. You're not going to see 2.1 on any box. You may see Ultra HD. I would tell you look for at least a cable that is rated to 40. It has to be rated to at least 40 gigabits per second, which means you'll get the maximum potential of any TV. 48, this means it's completely future-proof, all right? So short cables are easy. As long as there's 4 lanes of video, 4 video lanes in that particular cable that they could use, it will work just fine. It's when they get longer, is when it gets harder. This here, the next cable we're talking about is a longer cable. This is for 48 right now. The only cables that will go 48 have to be currently that are rated for 48 are all optical cables. So if I switch this cable on, you'll see that this is an optical cable. This is actually, they can go up to, I think, 30 meters on this cable. It has one side says source, one side says display. This can be powered off of the 5 volts built into your display, like most active cables can. Do not use it. Better cables come with a little almost way to power it from an external cell phone adapter. This ensures consistent 5 volts. If you use the TV, the display's internal 5 volt, it will fail on you 99% of the time because the voltage will drift. So basically what you're giving yourself is chances for dropouts, for video dropouts. If you do this, you won't get very many video dropouts. But if you don't use this, and I plug it into my Sony TV or whatever TV you fill in the blank, eventually that 5 volts starts to drift down on the TV, and all of a sudden the picture goes away. And the only way I get the picture back is to physically unplug the cable and plug the cable back in. Customers don't want to do that. So if you can use an outboard, the ones with the outboard power, to me, are the more reliable of the different cables that are available. The next thing, like we were talking about fiber. So fiber cables, like the fiber cable here, this fiber cable, which I have in my hand, these can support well beyond the 100 gigabits per second. So you put this in the wall, and you put the ends on this. The only thing you're going to have to replace in the near future, for a very, very long time, is just the converters that convert this fiber into HDMI to go into your cassettes. So this, even if they change the how a TV is connected, you can still use this cable. You would just have a different converter at the end on this cable. So this is a buy once, cry once situation for the customer. I tell people to run multiple Cat5s, multiple Cat6s, I'm sorry, and a piece of fiber behind every display, and that customer is good until we have flying cars, okay? So this is double the bandwidth of HDMI 2.1. All right, so people say, oh my God, what if I don't have active or optical cables? What am I gonna do? Well, there's a couple of things that I love. I saw this piece about 2 years ago. I thought it was brilliant. Say you ran a really good piece of passive copper. It's not active. It's a good piece of copper in the wall to a projector. And you know what? It worked great with HD. And then it worked great with 4K. But then all of a sudden, when I went to 4K 60p on my PlayStation or my Xbox, it wasn't working properly. Or it just can't handle the 60p from an Apple TV. What you can do with this is you put this on the display end of the cable that's in the wall, and then you put another little short one from this little box to the TV or the projector, and this will accelerate the capabilities of that copper. So your 10 gigabit copper now becomes an 18 gigabit cable for up to 15 meters, which is 45 feet. So these things are expensive. They're a couple of $100, but it's still less than the labor of pulling a new wire through the wall, or pulling a new wire through the wall and buying a new wire. So if this is a quick Hail Mary to get you to help solve many problems. But these guys are maniacs. So Brett told me about this one. This is the new one they're launching. This is the second generation. This one will, the old one basically amplified 3 channels in the wire, because that's what HDMI 2.0B was, and you got 18. The new one amplifies all 4 possible video channels on the line. So now this will take that piece of copper and go to 24 gigabits per second at 45, 50 feet. So for a lot of customers who go out and buy some new 8K projector, if it exists, a real 8K projector, and they have a real 8K inputs on it, I could put this on this device and hopefully utilize that cable, continue to utilize the cable without having to pull a new one through the wall. This will also take that copper cable and make it support up to 48 gigabits per second for up to 9 meters, which is what, over 27 feet. So this is a killer solution, and these are available through a company. If you go to Metro Home Theater, this is a lifesaver for many, many, many people who are looking for ways to utilize the cables you sold the guy a really expensive piece of audio quest or really, really expensive piece of cable, and this is a great way to extend the life of that cable. And this box is probably less than the cable, and definitely less than replacing the cable and the labor. Verified each cable is actually labeled. A lot of brands will tell you that a cable is that a series it will pass 18, and then in small print they'll say for meters up for distances up to 3 meters. So you need to make sure each box or each cable box that each cable is rated on that box or on that cable for 18. That is the only way you can guarantee it, because even in certain series on very good brands, the 18 gigabits or higher certification is only for the shorter distances. It does not rate it for the longer distances. You need to test your equipment, your cables. We already talked about that. I have that test pattern equipment that I told you where I can actually run a signal through it. You saw me do it with this white cable that I had in the house, and I can test it using these test pattern generators. These things can cost, the cheapest one is the Fox and Hound at about $2,000. Now, instead of testing, and the cool thing about it, I have actually said, I tested, is there a picture? Is there not a picture? These are automated, so I can plug the cable into the two of these devices and hit test, and it will automatically test all of the different sides. Yes, it can pass. Yes, it has 5 volts. Yes, it does HD. Yes, it does 4K. Yes, it does 4K 60p at HDR. And you'll see that white cable said no signal. It failed. So when I actually tried to play video through it, it failed. If you don't have money to buy these, and you want to check your cables, remember, Denon and Marantz AVRs have a built-in HDMI diagnostics tool built in. We don't share this with customers normally. We don't share because they can hurt themselves and mess up their receivers. Talk to your reps and your distributors, and they can give you the trade department, and we can give you the instructions on this. And this allows you to test your cables before you put them in the wall to make sure that they actually pass. And it's a great tool. The next thing, as I mentioned, receivers and TVs all have different functionality. So the Samsung TV doesn't support eARC, while the Sony and the LG TV may not support some other feature. So how do you know as a consumer, or even as an installer, what features are supported on that TV? Well, these bigger new test pattern generators also can give you status on that type of thing. This is that generator. The nice thing about this is most reviewers are going to have this generator. They're already starting to test all of the devices and all of the TVs. So within the next few months, you will know specifically by model and by series which things they support. If I go here and I look at the menu and I go into Eat It, I can check ARC. Does it do ARC? Does it not do ARC? How does it sync? There's data to tell me how many lanes does it have and how much can be supported through those lanes. I can test 2.0B cables. I could test 2.1 cables. I could test 2.1 displays with this box. So believe me, you will get the information. Now this piece is $5,000, and you go, oh my God, $5,000? I don't have $5,000 to do this. Do you have a less expensive solution? Yes, we do. We realize that if you have the receiver, you're going to want to know what the receiver is seeing and what the receiver is passing. So in the new receivers, not only will it tell you the resolution, you could test the cables, but it will also tell you what features are compatible with the display and the source device. So I can see if it can support eARC, auto latency mode, variable refresh rate, quick media switching, or quick frame transport, and I could see it across here. So the first time you connect these new receivers to a new receiver that's coming to a Sony, LG, or Samsung TV, you will know exactly what that display can do. So that's something that we added as well, because people always want to blame us for our feature not working, and we want the receiver will tell you, no, that TV does not support that feature. That keeps you from calling me. A couple more pieces I want to point out. a lot of times people ask me about problems with 5 volts, and I told you that some cables, like this little active cable here that I showed you earlier, this little active cable here that I showed you earlier, it is being powered by by the display. But if that 5 volts drifts on that display, and you have an optical cable, a very good optical cable, or a very good copper cable, whatever cable you have, if that voltage drops below a certain voltage, the picture is going to drop out. And we said always try to find an HDMI cable that has its own little cord off of it, so it can be powered externally. If you bought a really good cable, like an AudioQuest cable, and those do not have the external dongle to plug in via USB, you can buy this little 5 volt injector. This 5 volt injector will always make sure that cable is provided with 5 volts, which will prevent any dropouts and make it more reliable. The last one was we had a whole bunch of people from all over the world over the last few days, and they were complaining that they noticed that a lot of times Denon and Marantz receivers are having problems with their HDMI boards, and we uncovered, just like in the US, that a lot of times that has to do with the spikes in voltage coming from the cable boxes or devices that are connected. And people kept asking, is there a surge protector for HDMI? So I went searching and I talked to Brent at Metro Home Theater, and he mentioned they actually make one. So this is a little HDMI surge protector. So if you get little small voltage spikes from your cable box or your power lines, this helps make sure that it does not damage the sensitive video boards in your displays and in your receivers. Okay? And last but not least, the best way to ensure reliable long-term usage is to, of course, run fiber. If you can't run fiber, tell the customer, let me run a piece of conduit in here so I can pull, so it'll be less expensive for me to replace your wire in the future. So thank you guys very much for your time. And anything you want to add, Jim, before we let these guys go?
Yeah, Jen posted the link to the YouTube channel. And remember that the Q&A videos that Phil's going to put up are going to be based on the fact that we had like 3 pages of questions from people all over the planet. And
yes,
let's be honest, probably there'll be something in there that you may run into at some point. So
exactly.
those will be really beneficial, even though you all didn't have hardly any questions, because Phil did a perfect job as always. Thanks, Phil. You were great.
We spent an hour. Thank you. We spent an hour talking about those Q&A. So hopefully you'll find a little nugget in there that you may find interesting, because we've already saw this. You may just want to go look at the FAQ. So thank you guys very much for your time, and hopefully I will see you soon.